Hello friends, welcome to Shiksharthi. In this session, we shall be discussing the non-zeros of a function. So let's start. Now the prerequisite for this session are you should know about what is a function and you should know the investigative parameters of a function like domain, range, zeros, etc. Once you know this, in that case it becomes easier to take your learning to the next level, which is talking about the non-zeros of a function. So again, there are two aspects to this when we are talking about the non-zeros of a function. First aspect here is we'll talk about the non-graphical way of ascertaining the non-zeros of a function, and the next way here is the graphical way of ascertaining the non-zeros of a function. And we'll do this with the help of investigative parameters like domain, range, zeros, etc. Okay, so the first thing is when we say non-zeros, that means we are talking about a function fx. Let's say if fx, the function fx, is not equated to a 0. Now when I say it is not equated to a 0, that means the range of this function should not have an element like 0. This is the first point that you should understand. And when we are, so what we are doing is we are excluding one such range value of the function fx, and when we are restricting that, as a result of which we'll be restricting the domain values as well. So then all such domain values where f of xi, where xi is all such domain values. So let's say all these xi's where fxi is not equal to a 0. So when we say f of xi is not equal to a 0, in that case we are talking about all such domain values, and we know that all such domain values are just like saying x1, x2, x3, so on till xn, on which the function is not equated or equatable to a 0. This is what we are talking about. So when we are talking about this, as a result of which there is a discussion which is given rise to as a result of this. So the second point which is given rise to because of the point number 1 that we have discussed is the inequality aspect. So when we are saying that fx is not equal to 0, that means we are talking about two things primarily. We are talking about fx being less than 0, and the second thing which we are interested in knowing here is fx is greater than 0, which is fx is positive. That means we are either talking about the negative range of fx or we are talking about the positive range of fx. And when we are talking about the negative range, then we are interested in knowing all such domain values for which the function has a negative range. And in the first case, let us say that we are taking the values as, let's say, all such domain values x1, x2 and so on, let's say till xi, such that all such domain values where the range of the function is negative, and in the second case we are talking about all such domain values, let's say x1 dash, x2 dash, so on till xi dash, such that the range is positive. In short, when we are talking about the non-zeros of a function, that means we are not interested in the zeros, and we are talking about the non-zeros. The word non-zero refers to either lesser than 0 or greater than 0, which is either we are talking about the negative range of the function and thereafter interested in knowing all such domain values where the range of the function is negative, along with all such domain values where uh, the range of the function for all such domain values is positive. Okay, let us try and understand this thing graphically. For this, we would just take up a graph. Any graph which helps you to understand. So I am just taking a graph just for the sake of understanding. So let's say this is the graph that I have taken. Okay, let's put some values here. So for example, if I want to say that these are the zeros. Why do I say that these are the zeros? Because here on all such values of x, the value of fx is equal to a 0. So let me put them as x1, x2, x3. And for a better understanding, let's say this is the positive side of x-axis, this is the negative side of x-axis, positive side of y-axis, which we can call it as plus of fx, and the negative side of y-axis, which we can call it as, and then we know that on the x-axis I can say fx is equal to 0. That is why when we talk about the zeros of the function, we are basically talking about all those points which lie on the x-axis where the graph of that function would have intersected on the x-axis. And when we are talking about the y-axis, that means we are saying that this is nothing but when x is equal to a 0. So now if fx is equal to a 0, then what are we talking about? We are talking about all such values when domain values. So the domain values are f of x1, f of x2 and f of x3, and all these three values. So f of x1 gives you a 0, f of x2 gives you a 0, and f of x3 gives you a 0 is what I am trying to indicate with the help of this. Okay, so we are saying that f of x1 is equal to f of x2 is equal to f of x3, and all three of them have the same range, which is 0. Okay, but we are not interested in zeros, we are interested in non-zeros. That means we will exclude all such values, we will not even consider this, and we will talk about if fx is less than 0, then for which values of x. So fx is less than 0 when? So fx is less than 0 when we see that x is less than x1. This is one such case. Second case that we get here is we see when x lies between x2 and x3. So these are the two domain intervals that we get because of the restricted interval on the range of the function. So let's call it as if then, if then. Okay. Finally, when we say that if fx is greater than 0, which again is a part of non-zero, then let us find out all such values of x or the intervals of all such values of x such that when we substitute those intervals in the given function, the range of the function is positive. So the one first range that we can see from the graph is fx greater than 0 means the area on the graph above the x-axis, so which in any case we had already hinted it here. This is above the x-axis, and fx less than 0 means we are talking about the area which is below the x-axis. So here in this case we get what x is in between x1 and x2 union with x is greater than x3. So finally, if I have to make it as a writing on the wall, if I take fx is equal to 0 when we are talking about the zeros and the non-zeros, we would only talk about the domain and the range of fx, whether it comes to zeros or non-zeros. And when we are talking about this, then the restriction on the range of the function, either in terms of a zero restricts the domain to single or numerous values, but when we are talking about the non-zeros, it is a restriction on the interval of the range. So then the domain, the consequent to which when you're getting the domain, you'll get the restricted domain in terms of intervals. So the non-zeros will highlight the intervals and the zeros will talk about the specific values at which the function attains a 0. I hope you would be able to take this learning to the next level.